Hello everyone. Let us discuss a problem from the chapter of pair of linear equations in two variables. But before coming to the problem, let me explain you this. Suppose if we have the two equations which form a pair of linear equations a1x plus b1y plus c1, that is the first equation, and a2x plus b2y plus c2 equal to 0, that is the second equation. Now, if we have the ratio a1 by a2 is not equal to b1 by b2, then in this case, we are going to have exactly one solution, or our solution is unique. Now, the graphical representation of this will look like this. Suppose this is the x-axis, this is the y-axis, and the origin. Then we'll get two intersecting lines. Suppose this is a graph of the first equation, and this is a graph of the second equation, where we are getting intersecting lines. This point where the two lines meet will be the only solution to this pair of linear equations. In the second case, if we have a1 by a2 equal to b1 by b2 equal to c1 by c2, we are going to have infinitely we are going to get infinitely many solutions. The graphical representation of this suppose this is the line representing the first equation, then the line which represents the second equation will coincide with this first line. The two lines will coincide. We are going to get coincident lines. Now, in the third case, suppose if we have the ratio a1 by a2 equal to b1 by b2 and is not equal to c1 by c2, then we are going to get no solution. We are not going to get any solution in this case. And the graphical representation of this system will look like suppose this is the line that represents the first equation, then the line representing the second equation will be parallel to this first line. These two lines will be parallel to each other. They will not coincide, but they will only parallel to each other. We are going to get we are going to get parallel lines. So now we are going to do this problem. Let me read out the question. Determine whether the lines representing the following pairs of linear equations intersect at a point or parallel or coincident. Okay, let me do the first. The first system, that is 5x minus 4y plus 8 equal to 0, and the second equation 7x plus 6y minus 9 equal to 0. Here, now let us compare with this equation. Our a1 is equal to 5, our b1 is equal to minus 4, and our c1 is equal to 8. Our a2 is equal to 7, our b2 is equal to 6, our c2 is equal to minus of 9. Now let us find out the ratios. a1 by a2, it is 5 by 7. b1 by b2, minus 4 by 6. After cancellation, we'll get minus 2 by 3. And c1 by c2, we are getting minus 8 by 9. So what do we get from here? We are getting the ratios a1 by a2 is not equal to b1 by b2. We're getting the first case. a1 by a2 is not equal to b1 by b2. So we conclude, hence the lines represented by, okay, let me name this as 1, this as 2, represented by 1 and 2 intersect at a point. Intersect at a point means we are going to get exactly one solution. That is, we are getting a unique solution. Let us do the second equation, the second pair of linear equations. 9x plus 3y plus 12 equal to 0. Let me name this as 1, this as 2. Here our a1 is 9, our b1 is 3, our c1 is equal to 12. Then our a2 is 18, our b2 is 6, and our c2 is 24. We'll find out the ratios a1 by a2. 9 by 18, it will give us 1 by 2. The ratio b1 by b2, 3 by 6, we will get 1 by 2. Next, the ratio C1 by C2, which is 12 by 24, we will get 1 by 2. Here, A1 by A2 is equal to B1 by B2 is equal to C1 by C2. So looking from here, we are having the second case. We are going to get infinitely many solutions, and the two lines will form coincident lines. We conclude hence the lines represented by 1 and 2 are coincident. Now let us do the third pair. Six x minus 3y plus 10 equal to 0. 2x minus y plus 9 equal to 0. Here, our A1 is 6, our B1 is minus 3, our C1 is 10. Okay, let us first name this as equation 1, this as equation 2. Our A2 is 2, our B2 is minus 1, and our C2 here is 9. Let us find out the ratios. A1 by A2 is equal to 6 by 2, which is 3. B1 by B2 is equal to minus 3 by minus 1. This will give us 3. Then C1 by C2, it will be 10 by 9. So here, in this case, our A1 by A2 is equal to B1 by B2. Let us check. And it is not equal to C1 by C2. Not equal to C1 by C2. So we are getting the third case where we get no solution, and the graph representing by the two equations, we're getting parallel lines. Hence, we conclude the lines represented by 1 and 2 are parallel to each other.